In the past, if you saw somebody go up to a light pole and start talking to it, you might think the person was a lunatic. But very soon, if you saw that same person talking to a light pole, you'd realize that they're actually asking the light pole for directions, and the light pole would be providing the directions. So those are the types of applications that you'll see in smart cities. And I'm not making that one up. That is actually one that is being contemplated, and for all I know, maybe it's actually available in some city around the world. We have an excellent panel here to discuss the technology that makes smart cities possible. And we'll be covering items such as connectivity. You can't have a technology panel today without talking about the cloud. So we'll cover what is being done from a cloud perspective, basically services provided within advanced computing platforms to support smart cities. And we'll also be covering spectrum. A large part of 5G, as we move to 5G, is spectrum. So I'll be asking the panelists about what is the role of spectrum, what role will different bands play. And I'm going to stop talking and let each panelist now provide a quick opening statement to explain what types of technologies their organizations are providing for smart city applications, and an example or two about what kind of smart city applications their organizations are involved with. So I'm going to go in the order of what we have here in the agenda, and I'd like to begin with Hani Beshara of Eriksson.
Thank you very much, Peter. So when we think about smart cities, I think it's really a question of how do we integrate technology in a strategic fashion to better for sustainability, for economic development, and for basically the greater good of the citizens. So when we think about it, we also start integrating that with the Internet of Things, as building on what Eric was saying today. Eriksson is a telecom company. It's a vendor that actually basically looks at Internet of Things as two main layers, I would say. The bottom layer is really enabling the internet by looking at the platforms that would enable the Internet of Things. That would comprises of the things that provide all the different types of connectivity. It doesn't have to be wireless. It can be all the different technologies. It doesn't have to be cellular technologies. All the things we've seen actually, whether it's the Wi-Fi, the Zigbee and LoRa, and all the other possibilities there. As well as from an enablement perspective, definitely the cloud is a key enabler for the Internet of Things. So first layer is really all about the enabling the Internet of Things, which would be the basis for a smart city. The second part to it is all the products that also Eriksson provides into making that commercially viable. Because I think while we started by saying, imagine if it was free, the reality is that we need to make that commercially viable for it really to happen. So all the things around having, the applications for the Internet of Things, we foresee, for instance, just like iOS as an application, store, there would be a need for something like an IoT store, which anyone can be able to create apps for the Internet of Things that can take advantage of the data that got provided and stored in the cloud, which our expectation would be all of that would be completely available. So really two layers, and Eriksson's works in the base layer as well as in providing the end-to-end commercial applications as well.
Okay, Dr. Yang from Huawei.
Hi, good morning, everyone. This is Yin Yang. I'm part of the Huawei research in US in the wireless lab. as similar to Eriksson, we're a vendor and providing infrastructure for the cellular system. We're here more on the technology side, looking at what are the key gap or enablers we need to enhance the current technology in order to support IoT or smart city, these type of future services. There are two specific aspects my team is looking at. One is how to manage the increasingly complicated technology and the system. So we're talking about 2G, 3G, 4G, 5G. So any operator going forward will have all the mix of technologies. Into 5G, it'll be even more so. So reliability, when we talk about 5G, people tend to talk about fast speed, short latency, and so on. But reliability, I'm glad Eric mentioned that, is quite a different level of requirement if into IoT or smart city. So today you experience your service kind of data get cut down from time to time, but that's okay. But tomorrow, that's not acceptable. The other aspect we're looking at is cost. So people are talking about the marginal cost or approaching zero cost. That's obviously a vision on the wish list. Today, if we operate the network as it is now, the cost will be still too high to do that. Right? Think about millions or billions of devices into network, how to provision, get ready, get operational efficiency there. I think that's another big gap. One example, apart from the infrastructure side of the technologies, we're looking at to support smart cities. Actually, look at the user, the data, their trajectory, and so on. Obviously, we have a certain protection on the user privacy. So we look at anonymous data or aggregate data. So operator has a lot of this data. They know very well the user traffic, their movement, and so on. So we try to analyze those data using AI or machine learning type of technology to help the city planner to do for example, public transportation, where to design routes, how often, the schedule, and so on. So that is one example we're looking at. Yep.
Thank you. And now from Intel, Reza Arefi.
Thank you, Peter, for arranging this. It's always good to be back. Also, thank you for the keynote, very excellent, especially the mention of Moore's Law, of course. We live in a world that the increasing urbanization has created this potential for a lot of problems that fortunately technology could help overcome. We're being told that in a short 15 years, we're looking at over 5 billion people living in urban areas. And that is, if for nothing else, just for the sake of energy consumption, is a huge problem in our hand to solve. And a big task for smart cities to try to resolve a lot of problems, create new opportunities, and at a lower cost and lower energy consumption. When you look at the technology move in terms of connectivity from 2G to 3G to 4G and beyond, of course we all have heard about, and it was also mentioned earlier, move from voice to data to even more data. And there came along the app revolution. But then, in our view, 5G and beyond actually is one of a connected societies in a connected world, where everything and every device with any kind of processing and compute power would be connected to the network, to the rest of the world, to its surroundings and beyond, in order to increase efficiency, and lower energy consumption, and enable innovation, enable people with whatever they want to do, and it's actually there's no really ceiling for innovation once the mechanisms to achieve it are there. Just to give you an example of something that we're doing related to smart cities is which was also mentioned in the keynote, intelligent lighting and smart lighting. We're actually partnering with GE, who was supposed to be on the panel, on providing compute power to the light fixtures, where all sorts of data from all sorts of sensors, and these could be sensors for pollution, for public safety, for seismic information, for instance, all kinds of video, audio, everything. Putting all that, adding the analytics locally at the light fixture, and as much as possible, so we don't have to deal with going back to the core network and coming back in case there is an emergency or there's any need for any kind of strict latency applications, and this, again, there are lots of applications for this in terms of energy consumption. The 50 billion people that I mentioned, they put out about 80% of carbon contribution. And so it's very important for this future vision of the society to be sustainable, is to lower that in the way that it was mentioned that Copenhagen had done or wants to do. Just to give you another quick example of how this could be done, or one way, think about, we've all been looking for parking on busy streets where you slow down to look for parking and hold the traffic, and you get to an intersection, you don't know whether you should take your chances, turn right or left. All these, the smarts and the computation power of these light fixtures can map everything and give you real time where are all the parking spots in a few blocks around you, where you can just turn around. And just think about the amount of savings in terms of energy that could be done, among other things. So I just stop there, and we'll talk about details later.
Thank you. And from Nokia, Brian Hendricks.
Well, thank you, Peter. Thank you, Georgetown and WTA for having the symposium and for inviting us to talk. Like Eriksson and Huawei, Nokia is known primarily as an infrastructure vendor, although those distinctions are disappearing quickly, I think, as customers, including cities, are looking to us increasingly to not only provide the baseline infrastructure, and we certainly have lots of different technologies, particularly following the integration of Alcatel-Lucent into Nokia, but we're looking at 5, vertical markets that are very attractive to us. Smart cities is one of those. Intelligent transportation, connected healthcare, public safety, and utilities is a big one, which kind of goes along with smart cities. In terms of the technologies and the services that we offer that are of interest here, we're at a very exciting time. We do have all of the connectivity capabilities, including, by the way, for the gentleman who asked about RF emissions, a lot of capabilities to use existing non-radio infrastructure, including getting gigabit per second kind of speeds out of installed copper and things like that all the vendors have this type of technology that will be playing a role. In terms of the application and service side, we have something called Impact, which is intelligent management platform for all connected things. It's essentially a solution that provides device management and network management and data collection and analytics capabilities, which is a big part of being able to both make a business case for cities to deploy the technology, but also make big contributions to things like civic planning, transportation planning. I guess I will leave the bulk of my comments for the questions, except I would highlight a couple of examples where we have deployed. We're pretty active in New Zealand. We have found that to be a really good test bed for us. We are offering a smart storm drain situation, which allows for real-time monitoring of sewage facilities, which can provide for traffic redirection capabilities and detecting of anomalies and things of that nature, which is a very exciting sensor-based technology. We have provided also in New Zealand connected bus shelter capabilities, which is not just about providing connectivity and broadband capability, but also analytics and services to consumers. We have a deployment that we're working on in Singapore with a commercial entity to provide a nationwide narrowband IoT network, but there's a lot of machine-to-machine and sensor-based technologies that are going to be part of that, which are going to have applications in the smart city world. So I'll leave it there, obviously, and we can get into greater detail.
Thanks, Brian. I'm going to begin at the bottom of the protocol stack and talk about connectivity, and then we can move up the stack to the cloud. So a question for any panelist that wants to respond is, what do you see as the bandwidth and coverage requirements for different types of smart city applications? Are these all narrowband applications, all broadband? What do you see from your involvement and capabilities? Go ahead.
Start and then
I'll
Start down here at the end. I thought about a little bit about this when we were talking about preparation for the panel. Coverage is important, certainly. I think we think about more of the capacity issues. We have pretty well developed, robust LTE networks deployed today. In many places, those networks, and we'll talk about this, I think, in another question, are capable of supporting a lot of early use case ideas. But as we talk about things that require near zero latency, really high levels of throughput and reliability, things like a tactile internet where you're not just monitoring machines but potentially operating them remotely, autonomous driving, those are the kinds of things that are going to require considerably more capacity than we have deployed at the moment. And so you'll be looking at infrastructure solutions that both get you more performance out of what you have, but also densification of network deployments with small cells and distributed antenna systems. Within that, we will look at what spectrum bands are available. Some of them have better propagation characteristics for city environments, and some do not. So I think the short answer is we can meet a lot of the current projections with LTE and evolved LTE, but as we move to more bandwidth intensive applications that have near zero fault tolerances, we're going to need more capacity. That's the big issue.
Okay. Reza?
Thank you. Well, in our view, it's all driven by the applications. So it depends on the application. I'll give you just two examples. On one end, you could have a sensor network, a network of sensors where these sensors collect data maybe continuously, but then from time to time they wake up and they send their data and they go back to sleep again to save battery life. These sensors could be they don't have to be outdoors. They could be indoors. They could be several stories, several floors down, and they might need in order to reach them, or they reach the network, you need to use very low frequency so you get through and around obstacles and all that. So in that case, situations like that, when the amount of data is small, but then you need the reach and the range, narrowband IoT, for instance, which is already standardized, it would be a good candidate. But I'll give you another example. Think of an emergency vehicle, an ambulance, which is equipped with a two-way video conferencing capability. So some early triage could be done on the vehicle before you get to the hospital, and this vehicle could go at high speed, maybe 50, 60 miles an hour. That is a completely different kind of environment in terms of the amount of bandwidth and the channel that the vehicle goes through, communication channel that it goes through. So depending on the application, we feel that you would need low spectrum, you would need high spectrum to get the large bandwidth, and you need the mid-range spectrum for situations where you have to trade off coverage with capacity and support, for instance, high-speed vehicles.
Okay.
Yeah, I guess I agree with Brian Reza. Just to summarize my thoughts. So for any application, you need to look at probably at least 3 dimensions in order to pick up or decide. One is capacity or the bandwidth. The other one is latency. The third one is coverage. Right. So there are a few more dimensions you can look at it into as well, but these are the 3. I think the important ones. So, for example, very high bandwidth requirement. Either, for example, today 4G. I'm not talking. I'm looking at the wider coverage technology. 4G, obviously, 5G is targeting for that. For very low latency, I think 5G is trying to address that space. But if it's for example, for coverage, very demanding, for example, basement type of meters or whatever, you probably need low band. So it can be today's, for example, even GSM, narrowband IoT type of solution, or low band 5G and so on, right? So that's the dimensions I'm looking at.
Okay.
Great. I mean, not much really to add. I definitely agree with everything here. Maybe the only thing is if we look into, looking into the numbers, probably a lot. If you look into a network of sensors, probably tens of thousands could be, or millions for that matter, sending very few bytes, but and quite infrequently. So you're probably going to have more applications when it comes into a smart city that's sending very few bytes, but may need, as everybody said, depending on the application, coverage. Could be underground and so on. There are definitely other use cases, and applications would need high bandwidth, but probably going to be fewer of those.
So the range of bandwidth requirements is vast. Coverage requirements vary. We said the age of 5G, but by age of 5G, when we developed this conference, we meant the age where we have what we have and we're working on what comes next. There are a number of recent advances in LTE capability that will support smart cities and Internet of Things, and not every one of the panelists has to respond, but I'd like to just get on the table some of those capabilities somebody mentioned, and narrowband IoT, and there's also category M. So, Hani, can you maybe just explain those quickly?
Sure, absolutely, yeah. As an enabler, really, for the Internet of Things, 3GPP actually facilitated the creation of actually 3, I would say, global standards. One is really an evolution for GSM. It's called Extended Coverage GSM. And then there are 2 new technology, basically builds on top of LTE. One is the narrowband IoT, and the other one is Cat M1. Those 3, I guess, the whole the requirements that they are trying to meet are really extending coverage to meet basically the coverage requirement for the Internet of Things and for smart cities. And by that, they're looking into almost 15 to 20 dB increased coverage. That's one. The other one requirement would be obviously reducing the cost of the chipsets itself. That is very important as well. And by that is actually reducing the cost by 80 to 90% compared to just the LTE chipsets, for instance. Obviously, it will also depend on volume and so on, but the capability would be there. And then it would provide flexibility in how much the bandwidth that it would be supported, and the technologies will, for instance, narrowband IoT would support usually very narrow and very low bit rates. It's only 180 kilohertz, supports very low bit rates, while, for instance, Cat-M1 is a technology that would support higher bit rate, up to probably 1 megabits per second. So all of that actually completed by mid-2016. In June, I think the release 13 of 3GPP got finished from standardization perspective. So those technologies are actually now in development, and there is actually starting basically all the actual trials and the actual deployment of them in many places in the world have started. So that's from a wireless connectivity perspective. I think we are definitely on the path to be able to support smart cities and the Internet of Things.
Yeah, just adding that, sometimes we call it 4.5G, the LTE Advanced. So I think just to address some of the question earlier mentioned. So do we need to have to wait for the 5G, or I think 3GPP is doing a good job. It's trying to have a more evolutionary path into the future. So most of the applications or use cases probably we think about today already being able to support it by 4G, 4.5G, and obviously 5G will give us more capability, also in terms of cost perspective, hopefully much lower. But I definitely think we can start today. Yeah, that's just a point.
All right. I think it's important to note that 5G is not right now being designed as a replacement technology for 4G. That may happen one day, but my understanding, and maybe the panelists can comment on this, is that 4G will be around through most of the 2020s, and 5G will integrate with that. So does Brian or Reza, do you want to comment on that?
Yeah, I mean, I think most of the conversations that we have had with our commercial customers have been around, the short run, continuing to monetize and leverage the infrastructure that they have. What are the next steps of innovation that will improve upon that technology? And a lot of the conversations have now shifted away from the technology piece, because the technologists are busy working on 5G, is the business case discussions have started to happen. And where will it make sense to deploy new large radio interfaces, and where will it not? And what is the business case for that? And so we're having those conversations, and I think that's going to drive the timing on where you will see 5G technology begin to make its appearance. But I think that it isn't a replacement technology. In many cases, we're working on solutions as part of 5G that are designed to, really improve upon the architecture and the capability of LTE with better battery life and higher throughput and low latency and things like that. So those solutions can be integrated as part of advanced LTE and deployment of what we call 5G capable infrastructure that's capable of being upgraded to 5G. So I think that's what you'll see early, and then the larger 5G deployments will happen a little bit later.
Okay.
If I may add, with 4G, even though applications such as narrowband IoT have been standardized and now on the rise. However, the main use case or usage scenario for 4G still remains as mobile broadband, delivering high-speed data to smartphones and smart devices. The change going over to 5G, of course, we will have the enhanced mobile broadband and even higher speeds by going higher in frequencies and getting wider channels. But it probably what's most striking is the addition of other usage scenarios. According to the ITU, 5G will have 3 main usage scenarios. One of them is enhanced mobile broadband, of course, but the other 2 are are massive machine-type communications and ultra-low latency and ultra-reliable communications, which would, for instance, smart cities fall, for the most part, within that triangle of the three main usage scenarios. And it's the emergence of all these new applications that have their own requirements and their own technical and business challenges that will be addressed by 5G.
Let's look at the emerging or what the expected capabilities of 5G will be in a little more detail. Reza, you mentioned the low latency, high reliability. And can you or anybody else comment on what actual mechanisms are needed, such as traffic prioritization, to make that possible?
Yes, thank you. Yeah, very, very good question. A lot of these are new and emerging. People come up with new applications every day. Probably one example, which is actually related to smart cities as well, that kind of culminates a lot of these different aspects of 5G, including low latency, is the fully autonomous vehicle, the connected car. When you look at whatever that's needed in order to make it happen, aside from, self-park or collision avoidance radars that exist today and are being enhanced as we go. We've seen that major car manufacturers have announced that by about 5 years, these cars will be available. We will see them on the street. So one aspect is that, well, cities need to be prepared for that. Part of that is, part of the autonomous vehicle is communications with the infrastructure, in addition to with other vehicles and the cellular network, but also with infrastructures such as traffic lights and traffic signs and road conditions, weather, et cetera, et cetera. And when you look at all of these applications, some of these, the requirements are quite diverse. For instance, if you want to change lanes, if the car wants to change lane as it's moving, it needs to look ahead, so to speak, in 20, 30, 40 yards to determine whether the adjacent lanes are empty or not, where the lanes are, and then switch. So that does not require super low latency. However, when the car is stopped at a traffic light, the light turns green, wants to start, a pedestrian wants to cross. That is where you need the millisecond, the half a millisecond kind of latency. And even though the amount of information might not be, too large, however, that latency, that very low latency, puts a lot of pressure on the throughput that needs to be communicated and because to handle that situation. And it's being said that a connected car need about 1 gigabyte of information processing per second. So we can think of a connected car as a server on wheels, basically. So again, depending on the applications, we will see these very low latency applications. Another example, and I'll stop there. Another example is industrial automation, where in a lot of situations you will need to react very quickly in terms of millisecond in order to control industrial processes.
Okay.
And I'll stop there.
Brian, did you have any views on that?
I mean, I guess just in the broadest sense, I agree with all of that. I think when we look at this situation, we see many of the challenges are not technological challenges, in a sense that as far as being able to understand that you need to make distinctions about resource availability for certain types of applications, this isn't new. I mean, we've had application. What's the word I'm looking for here? Application-aware radio networks since 3G. You know, in the public safety applications, we're looking at ways that you can assign, communications protocols to give priority to certain people or certain services in an emergency. And so I think the technology will be there. I think the real question that I have to tease the policy panel a little bit is the extent to which commercial providers who are providing some of the connectivity and services will be allowed to make those types of decisions with net neutrality rules in place. We think that it's pretty ill-defined what a specialized service is or what network management includes and what it doesn't. So we'll need more clarity around that. And then, as I've mentioned in other places, there is some concern about the willingness and the business case for many to invest in expensive new network capabilities if there's an inability to monetize it by offering prioritization services and things like that. So I think that's a policy limit to me, not a technology problem.
All right. We're going to continue for a little while and take a few audience questions, and we'll probably end this panel around 10:45 and then take our break. So moving now up the protocol stack, what is the role of the cloud in smart cities? Hani, I know you do some cloud-related stuff at Eriksson.
Absolutely. The cloud is really the repository of all the data that will be coming out of all the the huge network of sensors that we're expecting. And I guess, so the cloud have to have a two-way, have to become a two-way street. It's not just a repository for data. It has to be also provides the interfaces to the APIs for all the applications that would be able to access this data, and has to be provide multiple ways of doing that to the applications on top. What's really also important on top of the cloud is the knowledge and basically intelligence that you add on top of the cloud. It's not just that you will store the data in the cloud. You have to be able to have the analytics on top of that would be able to cross-reference this data and be able to import any external data that's required for you to be able to make intelligent decisions. The reasoning is really almost what we're talking about here. Instead of in smart cities, we're starting by, today it's everything is more about reaction. When something happens, it tracks to it. What we want to move is to be proactive and then be even predictive. And the presence of this data in the cloud and being able to have that basically artificial intelligence on top, analytics, is key to be able to actually succeed. And it's also going to be one of the key aspects for monetizing and making this commercial. So be able to actually be able to use this data also. But obviously brings a lot of other concerns around security, brings a lot of concerns around regulations, but a place in the cloud where all the tons of data is being stored that's available is definitely it's a requirement and it's a challenge.
Dr. Yang, I understand that's your area of specialization. We're not talking about smart cities.
Right.
We're talking about really smart cities.
Mm-hmm. So, yeah, I'm thinking from two angles. One is, as Eriksson just mentioned, so the real value from IoT or smart city come from data, right? So you put all the sensors, all the connectivity together, really you achieve the benefit from the data. And the value from data come from, when you get the data connected, right? You can do the analytics on top of that. So a lot of technology advancement in the area of an umbrella of AI. Actually, one real example I can think about is when I came down here yesterday from Newark Airport, the parking lots. It's a short-term parking. It's very expensive. However, when you get in, it's almost full. I saw several tens of vehicles. They just go round. There's no spots, right? And then because I knew that, so I just go to a quite far away part. I know there's space there. So very simple use case application, right? So you put an LED. As part of the LED, you can put a Wi-Fi, and the Wi-Fi there you can do the video analytics. Very easy. You don't need to any big infrastructure costs, right? You just do the video analytics. You know where the spot is, and then you can guide. So the cloud-enabled data collection, storage, analytics. I think that's the key part of the value chain. Another thought is, I think Eric mentioned what to policy in terms of the regulation or the government role, and what to share. I tend to agree that you tell what instead of how. On the other hand, I think this is also a leadership role needed there. For example, if different function departments, they come to their own smart city solutions in a very disjointed way, that's going to be, you lost a lot of things, right? Not only the cost, but the value. So probably one of the leadership role from, government can be, or local government can be, for example, what are the platform, right? The cloud platform or data analytic platform capability. That can be designed, and application can be more different or by different functionality, but the platform can be in a much better design way.
All right, thanks. We could talk about cloud a lot more, but I wanted to spend a few minutes talking about spectrum. So Reza, you're involved with spectrum policy. A lot of 5G discussion today is about millimeter wave. Is millimeter wave the only spectrum band we need for smart cities? What's your view on the role of spectrum and age of 5G in smart cities?
Thank you. Definitely not. No. Millimeter wave spectrum has its own merits and its own application, its own use case. As for similar to any other spectrum, the characteristics, the propagation characteristics, and the physics varies, and that determines what's the best application for that spectrum. Again, as I said before, so if you're looking for long range, you wouldn't go towards millimeter wave spectrum because laws of physics makes you have a very short range, a lot of path loss, signals do not propagate, do not penetrate into obstacles. The signals do not bend around obstacles. As you go up in frequency towards the millimeter wave, you either have the signal or you don't, or a lot of scattered signal. But however, for applications where either because you have a huge amount of data to send and receive, or the range is short, but the latency requirements are so strict, then you have to have a big pipe in terms of throughput. Then yes, then you need very wide channels, and you can only find them as you go up in frequencies. And the reason there's so much talk about millimeter wave is because it's new, right? It's new at least for mobile applications. Is new. The technology advancements in the past decade or so have allowed us to be able to use those frequencies in a way that we couldn't before. And so, but it has its own place. It has its own applications. Lower frequencies have their own place because of the physical characteristics of propagation in lower frequencies. And so the short answer is no, and I gave you the long answer as well.
Brian, you have any views on spectrum?
A couple. I'm going to steal from Kevin's keynote here, and when you talk about there's no silver bullet, nowhere is that truer than with regard to spectrum. I think we commend the FCC and its millimeter wave proceedings for being comprehensive and aggressive, right? The certainty that comes to the vendors to be able to know that you have multiple frequencies to be able to design for gives you a great deal of flexibility. But there are limits to what the millimeter wave spectrum can do. And it might work comparatively well in Washington, D.C., and less of a viable solution if we're talking about trying to, provide a fixed access solution, in a more rural area, right? And so we need spectrum in many different bands, and that's often a hard sell politically because, the leadership thinks, well, we just did spectrum, right? So we need to leave it alone. No, actually, the answer is we have to constantly talk about spectrum, and I think the next great challenge after we finish out the FCC's proceedings on millimeter wave is to look next year at spectrum below 6 gigahertz. In particular, I think Nokia is excited about 3 gigahertz. We have 3.5, which is well down the road in terms of sharing with the development of a regulatory frame, but also with a sensing technologies. RFPs are out. People are looking at that. We think looking at the rest of 3 gigahertz, particularly 3.7 to 4.2 makes some sense there as well. Basically, the bottom line is that you're going to find both at the carrier customer side as well as cities, you want as much flexibility as possible because everybody has a different technology roadmap. The vendors have done what we can to, give the end-to-end solution set with the technologies, but everybody's starting at a different place. And so we need the flexibility that different spectrum bands can give us to design those solutions.
Thank you.